You know those classic sci-fi movies, right? Where some tiny creature gets zapped by radiation and suddenly it's this city-destroying monster. It's a really fun idea, but what if it actually happened? What if we took one of the strongest creatures on Earth, pound for pound, and just scaled it up?
I mean, just let that sink in for a second. An ant, but the size of a lion. It wouldn't just be a big bug. We're talking about a terrifying level of strength. This is a creature that could, in theory, just casually pick up your car, or yeah, even your entire house.
And that's all because a regular, everyday ant can lift about 50 times its own body weight. To put that in perspective, that's kind of like an average person lifting 2.5 cars. It is an absolutely mind-boggling feat of strength, all packed into this tiny little body. So if you scale that power up, you don't just get a giant ant. You get what is essentially a biological machine of immense power, a living, walking crane. An unstoppable force of nature that could literally reshape our world.
Which, of course, brings us to the big question. If this kind of strength is possible, why hasn't evolution ever produced a creature like this? Why are the most powerful lifters on the entire planet so small? Well, the answer, it turns out, has nothing to do with biology and everything to do with physics.
See, our titan ant has a fatal flaw, and it's one that's shared by every giant monster you've ever seen on a movie screen. It's a fundamental rule of the universe that you just can't escape, and it's known as the law of scale.
This right here is the heart of it all, the square-cube law. And it's actually a pretty simple rule when you break it down. When you make something bigger, its weight increases way, way faster than its strength does. And that's all because an object's strength is related to its area, but its weight is related to its volume.
Okay, so here's how it works. If you double an object's size, its area, and by extension its strength, it quadruples. That's 2 squared. But its volume and its weight grows by 8 times. That's 2 cubed. You see the problem here? Weight is in a race with strength, and it always wins.
So what does this actually mean for our poor, lion-sized ant? It means that far from being this unstoppable machine, the Titan ant would be a walking catastrophe. It'd be a creature that would instantly self-destruct under its own impossible weight.
Let's just walk through this pretty grim scenario. First thing, its legs would snap. Instantly. Their cross-sectional area just isn't big enough to support that massive volume and weight. Then, its entire exoskeleton would just crack and buckle under its own immense mass. And hey, even if it somehow survived that, it would suffocate. Ants breathe through these tiny holes called spiracles, and there's no way they could deliver enough oxygen to a body with that much volume. Game over.
And this right here shows you the result perfectly. Just look at the strength-to-weight ratio. For a normal little ant, it's off the charts. It's incredibly strong for its size. But for our Titan ant, whoa, that ratio just plummets. It would be pathetically weak compared to its own enormous body weight.
So, the crucial point, the real bottom line, is this. When it comes to the physics of life, bigger isn't automatically stronger. It's just heavier. That incredible power an ant has is a direct result of it being small.
And you know, this isn't just a fun thought experiment about ants. This law governs the shape of everything around us. From biology to engineering, it is a universal constraint on design, and you can see its effects absolutely everywhere once you start looking.
I mean, think about it. Why do elephants have such thick, sturdy, column-like legs? That's the square-cube law. They need that massive area to support their incredible volume. It's the exact same reason skyscrapers need these deep foundations and internal steel skeletons. And it's why a 1,000-foot-tall human is pure science fiction. Their bones would just turn to dust. This law is the ultimate answer to our original question. It's why insects are small.
So the big takeaway here is that while our imaginations can run wild, the universe has a very, very strict set of rules. And in the end, it's physics, not just biology or our imagination, that draws the blueprints for what is and what isn't possible for life here on Earth.
It really makes you think, doesn't it? The next time you see a skyscraper, or an elephant, or even a tiny little ant, you're actually looking at a brilliant solution to a fundamental problem of physics. Which just leads to one final question. What other invisible laws are shaping everything we see?